Hi guys, my name is Bappy Hamed and welcome to my YouTube channel. So guys, in this video, I'm going to show you one amazing research by Lightly AI. So recently they have developed one amazing product called LightlyTrain. I was exploring this product and I enjoyed a lot because if you see my personal interest in the computer vision domain. So I usually enjoy a lot whenever I work in the field of computer vision. So this is also related to the computer vision. So what is this lightly train? I'm going to discuss each and everything. Even I'm also going to show you how it is solving one very major problem statement. Okay, whenever you are working in the field of computer vision. So what is this lightly train, guys? So you can see this is the official website of this lightly AI. Okay, and this is the landing page of lightly train. This is the new interface they have created. So you can see train better models and faster, no labels needed. So here LightlyTrain is world first computer vision pre-training framework tailored for industrial application, train and deploy foundation models in a fraction of times and cost without the need for labeled data. Okay. So I think now you are getting a little bit what is this product is doing exactly, and what is the main problem statement they are solving. No need to worry if you're not getting it. I'm going to show you the entire demo. I'm also going to show the practical implementation. Then your understanding would be more clear. So first of all, let me explain what we usually do inside computer vision. Okay, so for this, I'm going to open up my Blackboard. So guys, I think you know that inside computer vision. So inside computer vision, let me take a new color. Computer vision. Okay, we have some tasks like we perform something called image classification. Okay, then we also perform object detection. We perform image segmentation. Okay, and so on. Some more tasks are available. I think you already know that. And what we do usually, let's say I want to perform image classification. I'm performing image classification. So what we do? So first of all, we'll try to label the data, right? First of all, we try to collect the data. Let's say I have collected cat image and dog image. So what I have to do, I have to label the data. Okay, label the data. And how we do the labeling operation inside image classification, I think you know that. We create individual folder. Let's say we create cat folder, and inside that we keep all the cat images. Okay, all the cat images we usually keep there. Okay, then we create another folder called dog, and inside that we keep all the dog images. Okay, and so on. So that's how we try to label the data. Now when it comes to object detection, okay, when it comes to object detection, so here also we do the same thing. First of all, we try to collect the image. Let's say we collected some dog images. Okay, dog images we have collected, or let's say cat images we have collected. So now what we have to do, we have to again label the data. We have to label the data. So here we also call it as annotation. Okay, we have to annotate the data. And how we annotate, let's say this is our image. This is our, let's say, cat image. Inside the image we have a cat. I'm not good with drawing, but just try to consider this is a cat. Okay, this is a cat. So we have to annotate the image. Let's say we will be creating a bounding box like that. This is a cat, right? This is a cat, and this coordinate point we just try to save inside our annotation file. Let's say we are using YOLO annotator. So for this we can create a txt file, .txt file. In the .txt file we just try to save all the annotation. Then we pass the image as we and we also pass the annotation to the model. That means again it's a supervised learning. We are passing the input image, then we are also passing the output. That means my annotation, and my model is learning. Got it? And what kinds of model we usually train inside computer vision? So most of the time we use something called pre-train model. pre-training, okay, model. Pre-training model. What is pre-training model? This model is already trained with some specific data. Let's say whenever I'm talking about image classification, so this let's say model is already trained on something called ImageNet data. ImageNet data, I think you know that ImageNet is a benchmark data. It's a benchmark data. Okay, so whenever any research come, they usually take this data and they train image classification model. If I'm talking about object detection, they use something called COCO data. Okay, COCO data. So COCO is also benchmark data for the object detection. So for OD, and this is for classification, OC. Got it? So that's how if you go ahead, you will see that for different tasks, they use different kinds of data. But if you see this ImageNet data and COCO data, so these are having some specific classes. Okay, so I think ImageNet is having 1000 classes. Okay, 1000 classes it is having. And in the 1000 classes, it is having, let's say, bus, aeroplane, okay, aeroplane, then person. That's how actually there are different objects are different actually category, different classes are available. If you go search over the Google ImageNet 1000 class list, you will see different classes are available. Let me show you. So if I come here, if I search like ImageNet 1000 classes, sorry, 1000 classes list. So maybe there are some website, they will show you the classes name. So guys, here you can see the classes name. So you have see tench, tinka, then a goldfish, then you can see hen, then see different like category you have here. Okay, different category you have in that particular image, and I think it is having 1000 classes. If I show you 1000 classes, it is having, okay, because it's starting from 0 and it's ending 999. Okay, so these are the like 1000 classes it is having. But apart from this 1000 class, if you have any other classes, then what to do? Will this model will be able to classify? Definitely not. This will fail. So for this, what we do, we just try to fine tune the model, yes or no. So we take the, let's say, same model. Let's say I'm talking about ResNet. Okay, so ResNet is also image classification model. It is already trained on COCO data. Now, if I have any other class, let's say I have any other class. Okay, I have a very specific class. Let's say I have mobile phone. Let's say mobile phone data is not available in the ImageNet data. So what I have to do, I have to take the mobile images. Then I will be doing the annotation. That means we'll be doing the labeling. Then we'll be fine tuning the ResNet model. Then my ResNet model will be able to classify the mobile. Otherwise, it will not classify. If I'm talking about for the object detection, so there we also use something called pretrain model. Like there are different pretrain model are available. Like nowadays, very popular, you will see YOLO. Okay, YOLO V5, V6, V7, V8, V9, then V10 is also available. Even V11 is also available. So these are like very popular model, right? Very popular model, and this model is already trained on COCO dataset, something called COCO dataset. Okay, and COCO is having how many classes? I think 80 classes is it having. So if I search here, COCO 80 classes list. So again, here I will see the order. Okay, so see, these are the 80 classes you have, like background, person, bicycle, car, and so on. Okay, 80 classes this COCO dataset is having. But apart from these 80 classes, if you have any other class, let's say you have sign language. Let's say here I'm showing my hand like that. So this is called hello in American Sign Language. So if I give this particular hand gestures to the model, your model will not able to detect because this data is not available inside my COCO data. Then what I will do, I will collect the sign language data. Okay, I'll do the annotation. Okay, you can also call it as labeling. Then what I will do, I will pass this labeling, or I'll pass this image to the model. Okay, that means YOLO model. Then my model will be able to train. That means we do the fine tune here. Okay, we'll try to do the fine tune. Then my model will be able to detect this is a sign language. But what is the major actually, let's say, problem? What is the major, let's say, difficulty you face here? Okay, I think you know that. Those who are working in the field of computer vision, I think you know the difficulty. The difficulty is something called data labeling. Data labeling, because here you have to do the labeling manually. There are some automatic tool also, but at the end you have to do your manual observation whether these tools are labeling your data in a correct way or not. Again, manual observation is required. Let's say you have let's say 10,000 images, 10,000 images. So you have to annotate 10,000 images manually. You have to observe 10,000 images manually. Then you will be able to make sure that you can train these other data with your model. And this is like very costly task, very costly, very time taking, okay, and very like hard task in the field of computer vision, this data labeling, right? Because the time you spend in the model training, okay, it's like very less, but whenever you annotate the data, whenever you label the data, it takes actually most of your time, okay, and you can't focus to any other problem statement or any other let's innovation. Got it? So to prevent these kinds of issue, so this Lightly AI, they came up with something called LightlyTrain. Okay, they came up with something called LightlyTrain. So with the help of LightlyTrain, what you can do, you can train these kinds of foundation model. You can deploy these kinds of foundation model. Okay, in just a few line of code. Okay, in just like a few minutes. Okay, few minutes you can train the model with the reducing the time, with the reducing the cost without labeling your data. Okay, amazing, right? So this is the first like computer vision like a pre-training framework they have developed, and it supports actually various kinds of model, like it supports YOLO, it supports actually your computer vision classification like baseline. Okay, so these are the model actually it supports. So guys, you can see this is the official website. You can come here, lightly.ai, LightlyTrain. So you'll be able to see they have also given the demo. Even you can see there are different example they have also given. They have given their benchmark. Okay, you can see amazing benchmark. It is working. Now see how to install LightlyTrain, how to run the pre-training, how to do the fine tuning. Every example they have given. Okay, so I'm going to show you the like practical demo. After that, I think your understanding would be more clear. Now you can see this is the official GitHub of this LightlyTrain. If you're interested, guys, you can also start. You can also explore their GitHub, because this is completely open source. Even if you are facing any issue, you can also create the issue. So they will be fixing your issue immediately. You can see. So they will be fixing your issue immediately. Okay. So this is the entire research. Even in the GitHub also they have given the example code. Okay, how you can use this LightlyTrain. So guys, now you can see this is the documentation of LightlyTrain. So here you will be getting all kinds of installation guideline, training guideline. Okay, so all the things they have given. Even if you want to connect with Docker, everything they have given. So you can see, guys, LightlyTrain brings self-supervised pre-training to real-world computer vision pipelines using your unlabeled data to reduce labeling cost and speed up the model deployment, leveraging the state of the art from the research. It pre-trains your model on your unlabeled data, domain specific data, significantly reducing the amount of labeling needed to reach high model performance. Okay, this allows you to focus on new features and domain instead of managing your labeling cycle. LightlyTrain is designed for simple integration into existing training pipeline and supports a wide range of model architecture and use case out of the box. Okay, now wide LightlyTrain, no labels required, domain adaptations. Okay, then you have a model and task agnostics, then industrial scale supports, and this is the installation guideline and all the example code they have given. Now guys, let me show you how you can use this LightlyTrain for this kinds of supervised pre-training. That means here you don't need to pass your label data, only using your let's say raw data you can train some amazing model to very specific domain specific data, right? And we'll be using some existing model like YOLO. Okay, with the help of that we'll try to do these kinds of training. So for this, guys, what I have done, I have created a like collab notebook here, and all the resources I'm going to share in my description section. From there you can download and you can try with me. So guys, first of all you have to select your GPU as a runtime. So let me select my GPU. So you can see, guys, when runtime type. So here I am using free collab, that's why I'll be using T4 GPU. Let me set. Now let's connect the notebook. So once it is connected, you have to install this LightlyTrain. Okay, and I also need Alterytics, because if I want to access the YOLO model, so it is available in the Alterytics package. And to visualize your image, you need the supervision. Okay, supervision. So supervision is the product of RoboFlow. So they have created this library. So with the help of that, you can visualize your images. Okay, visualize your detection and all. You can do everything. So for this you can use the pip package manager, because this LightlyTrain is also available as a pip package manager, let's say PyPy package. You can also install from here. So let me install everything. So after that, we'll try to get one data, guys. Even if you have your custom data, let's say if you have any data in your local directory, you can also upload. But as of now, I don't have any data. So what I will do, I will just try to download one data from the Alterytics. Okay. So here I'll show you the data set. So the dataset name is VOC data. Okay, VOC data. I think Pascal VOC data. So it is having some image as well as the annotation, but I'm only going to use the image. Okay, not the annotation file. So this installation will take some time, guys. I'll pause the video. Once this installation is complete, I'll come back. So guys, you can see installation is done. Now it is asking for the restart your session. So let's do it. Now it will reconnect. So after that, let's try to download the data. So guys, you can see it is downloading the VOC data from the alterytics.com. So this is the zip file. After that, it will also do the unzip operation. So here in the datasets folder, it will download all of the data. Okay, you can see the VOC, and inside that you will see all the images. Okay, as of now it's a zip file. Once this execution got successful, it will also unzip that like zip file. So guys, as you can see, my execution is complete. Now if I refresh and if I go inside VOC images, so you'll see we got test, train, and validation image. Okay, so let me show you some images, guys. So let's say I will open this folder and see, these are the images actually we have downloaded. So you have actually some furnitures, okay, in the room, because this is the object detection data. You can detect any kinds of object. Then you have cats. Then you also have okay, cycles, then persons. Okay, these are the like let's say example you are having in this data, and it is also having the label, but we don't need the label. Okay, the label I'm not going to use, so I'm only going to use the images. Okay, and I will try to do the training operation with the help of this LightlyTrain. Okay, and I will show you the beauty of that. Now if you want to get that dataset directory, so you can execute this code, and this is your dataset directory. It is available inside content datasets. Okay, so guys, now let's visualize some example with their original labels. So for this, what I'm doing, I'm importing some necessary library, and I'll be using supervision for that. Now, first of all, I'm loading the YAML file. That means the annotation label, because I want to show the original annotated like image. Okay, that's why I'm loading it. Then in the supervision, I'm giving the YAML file path and the like training image directory. Okay, you can see I'm giving the training image directory, and also I'm giving the annotation directory. Okay, so once you give that, so see, this particular code will load that image and load the annotation, and it will show the visualization. So see guys, these are some example. So see, these are some actually labels and your original annotation, like this is dog, this is dog, this is TV monitor, this is person, this is cow, this is cow. Okay, now we will be seeing that how we can let's say do that like training operation without giving any kinds of label data. So for these guys, this is the code. Okay, so here I'm importing LightlyTrain, and I'm also importing Alterytics settings. Okay, now here you have to give the dataset path. Now you can see I'm only giving the training image path. Okay, I'm only giving the training image path here. Okay, this uh 2012 series data I'm using. Okay, because it is having different series, 7, 12. Okay, these are the series it is having. I'm using 12 data. So you can see inside that we have some training image. Okay, snake is also there. So we are giving this path. Just copy the path and mention it here. Then this is the code, LightlyTrain dot train. See, very simple, very simple, just one line of code, LightlyTrain dot train. Here you have to give the output directory. That means after training, where it will save all the models, where it will save the artifact. So I'm going to give this particular directory. Then your model, which model you want to use. So here I'm telling that I'll be using Alterytics YOLO V11 model. Now if I go to the YOLO V11 GitHub, it is having different model version. So I'm using the smallest version of the model. Okay, so if I show you the object detection baseline, see, YOLO N is there, S is there, MEM is there, L is there, X is there. So N means nano, small, medium, large, X large. Okay, so I'm using S model. Let me small model. So here let me show you a small model I'm using. Okay, so it will download the configuration file and it will load the model. And with this model, actually it will do the fine tuning operation on top of your data. Okay, then I'm giving the data path and number of epoch. So guys, in the training folder, I have lots of images. So that's why I have given one epoch as of now, just to show you. Okay, quickly training. I want to show you. That's why I've given one epoch. But whenever you are training the actual model, make sure you are increasing the epoch size. Okay. So here you can increase the epoch size. At least you can train with 1000 epochs, or let's say 500 epochs you can train. You'll be getting actually some detection. Then batch size is equal to 64. As per your machine configuration, you can assign. Now once everything is set, guys, so see guys, here I am not here I haven't given any kinds of label. Okay, I have only provided the image. Okay, now automatically it will try to understand the labels and it will try to fine tune the model. Now let's start the training. So see guys, my training has started and it has downloaded the entire model, YOLO 11 model, and this is the model configuration. Now see, my training is going on. And here you can see the losses, okay, the MAP score, everything you'll be able to see that. And then after training guys, we'll try to load the training model and you can do the inference on top of that. But see, I'm training only one epoch, that's why you won't be seeing any detection. But whenever you are training like multiple epochs, definitely will be able to see the detection. Okay, so here let me unexpand. Now if I refresh, see, output folder has created. Inside output folder experiment, it will save all the artifacts. Okay, so let's wait guys. Once this training is complete, I'll come back. So guys, as I can see, my training is completed. Now if I refresh, if I go to the output folder experiment, and if I go to the checkpoints, no, not checkpoints, exported model. So here is your trained model guys. Okay, now this model you can use. And how to load the model, I think you, those who have already used the YOLO, I think you know that. Just first of all try to import the YOLO, and inside that just try to give the model location. So here just copy the path and here just give the path. Okay, so it will load your model. Then once you have loaded the model, what you can do, you can let's say get some data images. Okay, so let's copy from the test. So let's say I will download this image. Okay, after that let's upload it here. Then I will rename the file, let's say test.jpg. I'll copy the path, or you can also give like that, test.jpg file. This is jpeg file. Okay, now let's do the inference. So here we are passing the image, okay, to our model. The model actually we have loaded, you can see the model. I think you can see this is the model. Okay, inside model we are passing, and whatever results we are getting, we are visualizing, okay, with the help of our this visualization. Now see here, it is not giving any kinds of detection because here we only trained one epochs. Okay, that's why. But whenever you are training multiple epochs, definitely will be able to get the detection like that. Got it, guys? So yes, guys, this is like one amazing research done by this LightlyTrain, and you can export, okay, because it will help you a lot. It will reduce your like time, reduce your cost definitely. So I'll provide all the resources in my description section. From there you can get it. So yes guys, this is all from this particular video. I hope you liked it. So if you have liked my video guys, please try to subscribe to my channel, try to support my channel. With that, thank you so much for watching this video, and I will see you next time.